Assalamu alaikum students. In today's lecture, we will solve exercise including its MCQs and short question answers. Numericals are also given at the end, but they are not solved. You have to solve them yourself with my help. Okay. Now here the MCQs are mentioned. Wave mechanical model of the atom depends upon de Broglie's concept, uncertainty principle, Schrodinger wave equation, or all of the above. The answer is all of above. Here, I'm going to mark it. This one is all of above. For which species Popper's theory does not apply? So it is not going to apply on the multi-nucleated or the multi-electronic systems, which is beryllium. All the other three are the monoelectronic system. From the discharge tube experiment, it is concluded that mass of a proton is in fraction. Matter contains electrons, nucleus contains positive charge, and the positive rays are heavier than protons. The answer is matter contained electrons. This one, the B part is okay. Now the next one is when an electron of the charge E and mass m moves with velocity v about the nuclear change z nuclear charge Ze in the circular orbit of radius r. The potential energy of electron is given by minus Ze squared upon r. As I told you that the potential energy of the substance will be with the negative sign, that is decrease its potential and coming to that of the fixed part into the orbit, right? Now here the next one is which of the following quantum numbers is not obtained from Schrodinger wave equation? It is spin quantum number. This one is right. Now here electronic configuration of M2 plus sign is given. The total number of electron comes out as 24. Atomic weight is also given. It is 56. Is asking you for the neutrons present in the species M. Right. This element, as you know that the number of proton and number of electron is equal in the neutral atom. Here it is an ion. And it is carrying 2 plus charge. So it means 2 electrons are less. Add these 2 electrons also into this configuration. It will comes out as 26. So subtract this number from 56. We will get the number of neutrons. It is 30. In the second one, next one, seventh one, MCQs, the energy of magnetic radiation is 3 × 10⁻12 Earth. What is its wavelength in nanometers? Answer is 662.5. For this, you have to apply the formula E is equal to hc upon lambda. From this, you have to take out the value of lambda. For energy, convert this value into joules instead of the earth, so that you can get the value in the in nanometers of this lambda. Here it is given that the relationship between joule and earth is 10⁻⁷ earth is equal to 1 joule. So 3 × 10⁻12 earth will be equal to how much? That is 3 × 10⁻12 upon 10⁻⁷ earth. So it will come out as 3 × 10⁻17. Find out lambda from it by applying all the parameters in it, that E energy, then Planck's constant, H the value of H, and then C the value which you will get is 662.5. Right. Now here the next one is, as the answer will come in meters, but you have to convert it into nanometers, as 10⁻⁹ meters is equal to 1 nanometer. So use this relation and then convert it into nanometers. Now the next one is which of the following configuration is not correct according to the Hund's rule. Hund's rule says that when degenerate orbitals are orbital, you have to half fill them first, right? So apply it. Here all the orbitals are filled equivalently, so this is not your answer. The answer is C, where there is availability of an empty orbital, but we have placed the 2 electrons with the opposite spin in the other orbit, although all the 3 are the degenerate orbitals. So this C option is incorrect. Right. Now in ninth one, which one of the following statement is incorrect? It is D option, which is not the radius of the first orbit. 10th one says which one pair is not isoelectronic. Isoelectronic are those species which have same number of electron in them. Mg after losing 2 electron, 10, 12 minus 10 becomes 12 minus 2 becomes 10, and beryllium after loss of 2 electron 4 minus 2 becomes 2, so they are not isoelectronic. N minus 3 and O minus 2 both acquire 10 electron each. They are isoelectronic as N is 7, and with minus 3 addition of 3 electrons it becomes 10. Oxygen with atomic number 8, after addition of minus 2 it becomes 10, so they are isoelectronic. Nitrogen with minus 3 and fluorine with minus 3 get 10 each, and fluoride minus 1 and Al plus 3 both will carry, as fluoride minus will carry 10 electrons. Atomic number of fluorine is 9, while aluminium having atomic number 13, after loss of 3 it becomes 10. So all these are isoelectronic except that of option A, that is Mg and Be. The third line in Balmer series correspond to an electronic transfer between which Bohr's orbit in hydrogen. You know very well, in Balmer series the substance, the electron has to jump back into the second shell, so it will be the B option, that fifth one orbit, say it will be back to the second one. Then the next one is there given. Okay, it's over now. Now here some of the questions are being given. I have not answered all the questions, but I have answered some of the questions which are as such directly not given in your book. One of them is, now here this one short question, that how mass of electron can be calculated from E by M ratio and charge. It is the second question, first one in the part of the second question. So it is given under the heading of the Millikan's method. It is calculated, so you have to take it from there directly. The second question, that how does Mosley's law help in the production of X-rays, that is also given under the heading of X-rays. So with the formula it is given, so you have to take it from there. The third one is, which quantum number is also called the subshell quantum number. It is also given under the heading of the azimuthal quantum number. In the slides it is also given, so you can take it also from there. What is the difference between orbit and orbiter? This question is answered here, as the orbit represents the planar motion of the electron in a fixed one shape of the circular orbit, while the orbital is the representation, that is the three-dimensional motion of the electron around the nucleus. Orbits are circular while they are differently shaped. You can call them as S with the spherical shape and dumbbell shape of P, and the double dumbbell shape of the D, right? Now orbits are the well-defined parts that revolving electrons follow around a nucleus, while orbitals are the regions in space where electron can be present, or you can say it is where the probability of finding an electron is maximum. This is the region where the probability of finding an electron is maximum. Now there is no any satisfactory answer given for the orbits by means of the Heisenberg uncertainty principle, but the orbital concept is completely explained by means of the Heisenberg's uncertainty principle when we are treating it like a wave, right? Now the formula used for the filling of the orbit, it is 2m square, by which you can find the number of electrons in each shell, and they are represented by K, L, M, N, that is n is equal to 1 or 2 or 3 or 4, K, L, M, N, etc. Now orbitals, each orbital can hold only 2 electrons in it, is it? With the 2 electrons in a paired swing. Now the 3D movement of electrons is given by the S orbital, P orbital, D and F orbitals. They are specifically shaped, that is S which represents the spherical one shape, P once again the dumbbell shape, D with the 5 orientations in the three-dimensional space, and F with the 14. You know very well how many electrons can be accommodated totally in them. S can hold 2, P totally 6, D with the 10 and F 14 electrons. So this is the answer, a perfect answer for your question. The next one is given, what is the relationship between Fifth one question is this one: energy and wavelength and frequency and wavelength. This is given by the Planck's quantum theory, as I have represented here as well. This is given that the first one, it is showing you the relationship between wavelength to the energy. This is given by E is equal to h nu, and nu is equal to c by lambda. Nu is equal to c by lambda. So by putting this value, E is equal to hc by lambda, you can see E and lambda, they are in inverse to each other. Means if the longer waves are there, energy will be the long waves, means energy is low, and short waves means energy is high, as they are inversely related, where h is the Planck's constant and c is the speed of light. Here the relationships are going to mention, and to give you the but to say the explanation, wavelength and frequency are inversely proportional to each other. Higher the frequency, greater is the energy of the wave. The shorter the wavelength, the greater is the energy of the wave. Here in this second diagram, there is mentioned the relationship between frequency and lambda. As I told you earlier, the first one picture is also giving the relationship of both energy and lambda as well as frequency and lambda. Here it is also frequency is inversely related to lambda, as it is given. You can see the different number of types of waves are being mentioned here. So what will you say? Longer is the wave, shorter is the frequency, and shorter is the wave, longer or higher is the frequency, as they are related inversely. So similar is the, as frequency and energy are related directly, so you will say the energy is higher for the high value of frequency, and energy is lower for the low value of frequency, right? So this is your right answer for this question. Now here next one is, the hydrogen atom and helium are monoelectronic system, but the size of helium is much smaller than that of hydrogen. Why? There the explanation is mentioned. As you know very well, in helium and hydrogen both have only one orbit. In hydrogen there is only one electron, but in the helium there are present two electrons. Similarly, in the nuclei of hydrogen there is only one proton present, while in helium there are present two protons in it, right? So the attraction of the two protons for two electrons. Now this time it is helium with the plus sign. What do you think about? When it is a plus sign, it has lost one of its electron. So what happens? Two protons equally are attracting a single electron present in the outermost shell. So attraction is higher as compared to for hydrogen, when where there is 1-to-1 attraction, that is one proton is attracting only one electron, while in helium plus two protons are attracting only one electron present in the first shell. So the shell size will shrink due to this force of attraction between proton and that of electron, right? This is your correct answer. Now next one is given, the what you say, the question is how the wavelength of the moving particles are related to the momentum of electron. This topic is directly not given in your book, but it is related, as it shows you the dual nature of the particles. It says that particles can behave both as waves as well as particles, right? So as the electrons can behave both as the particles as well as waves, so similarly the matter, the particles, they can also have a wave nature. This relationship was given by de Broglie, right? So here it is given. It has been observed that light displays a dual nature. It acts both as wave and as a particle. Assuming symmetry in nature, the French physicist Louis de Broglie proposed in 1924 that particles should also possess the wave-like properties. And here the momentum is shown of the photon of light, that is P, which shows the momentum, is equal to h over lambda, where h is the Planck's constant and lambda is the, what you say, lambda is the wavelength, right, of the photon. photon is the quantas of energy. Right? Now, de Broglie suggested that momentum of a material particle which is having mass m and the velocity v, its momentum can be given as that momentum is equal to mv. You can see above here, when wave was there, it was taken as the h over lambda, that is momentum, and when it is behaving as a particle, it has momentum mv. Relate both of these, both of them are the momentum, so h over lambda is equal to m mu, and if you take out lambda from it, so it comes out as h lambda is equal to h upon m mu. Right? Now here this is the relationship between that of the wavelength and that of the momentum. Here it is given. Right? So this is called the de Broglie's wavelength, or which shows the dual nature of the particles, just like that of the electrons. Right, Ji? Now here next question is, what is Heisenberg's uncertainty principle? Under the defects of the Bohr's atomic theory, again this Heisenberg's uncertainty principle is mentioned, but here I have elaborated it with that of its formula as well. It was given by Heisenberg in 1927, so that he got a Nobel Prize as also for this. This principle gives a very vital relation between that of momentum and position of an object, according to which the position and momentum of a particle cannot be simultaneously measured with arbitrarily high precision. Means आप बिल्कुल exact नहीं कह सकते कि here the particle is present and this is its momentum, right? So there is a minimum for the product of the uncertainties of these two measurements. Here it is given the formula which is formulated for Heisenberg's uncertainty principle. It is delta x, which represents the uncertainty in position with respect to that of along with that of the uncertainty in momentum, which is represented by delta p, more or less than that of the more or equivalent to that of the h over 4 pi. जो given आपके पास में waves हैं, उनके रिलेशन से वो कह रहा है आपके पास में, या ऑर्बिटल्स के लिहाज से कह रहा है that you cannot find the exact position and momentum of the particle. The more accurately you know the position if you have found, so delta x की वैल्यू उसके लिए स्मॉल होगी, लेकिन दूसरे ही केस में you cannot find the momentum of the substance, उसकी delta p की वैल्यू बहुत large आएगी, and if you want to go for the momentum, vice versa will occur. So this is what's called as Heisenberg uncertainty principle. Not a detail of it is given in your book. It is beyond your course, so I'm going to leave it here. The next question answered is, write electronic configuration of. I think you can write it well yourself. As I have told you all the rules that you are going to apply, Upper principle, you are going to apply N plus L rule, you are going to apply Pauli-Fluvian principle and Hund's rules. So I'm not going to discuss it here, but you have to do it yourself once again. Right? Now following all the rules. I hope you can write it well. Then the next one is, what is N plus N rule? As I told you earlier, N belongs to the number of shell. It represents you the that first shell or second shell or third shell or whatever, and L represents the azimuthal quantum number. The sum of these two will tell you that which orbitals will be filled first. This was given by Weisweiser, and so that's why the rule is called Weisweiser's rule. So according to this, you have to find out the N plus L value for each orbital, so you can get which orbital which carry the lower number of N plus L, that will be filled first. Okay. Now the next one is here, the question number 13, that a diagram is given and you have to find it out that what happens. Let's just say look at the diagram and deflection of the cathode rays. What do you understand when cathode rays strike at? Now look at the diagram very carefully. Here it is given a magnetic field, here it is given an electrical field, and you can find here when none of them is being applicable, right? दोनों ही present नहीं है तो फिर क्या होगा? Point 1 पे कब fall करेगी, point 2 पे कब fall करेगी और point 3 पे कब fall करेगी? If you remember, we have done it under the heading of what you say J.J. Thompson's E by M ratio when it was calculated. I have explained it there, right? So you can see that when it is at point P1, it means that it is not under the influence of any field, it is direct, uh, hitting to that of the screen. The cathode rays actually are directly hitting to the screen. There is no influence of the electrical field or that of the magnetic field, or you can say when both the fields they have same strength at the, then once again they will fall at the same point, no influence of any of them, right? When it has turned to that is P3, point P3, it means it is under the influence of electric field. As you can see, it is moving towards the positive terminal, जो up ऊपर की तरफ को +1 आपको शो किया हुआ है. This is the positive terminal of the electrical field. Similarly, P2 represents when the cathode rays striking under the influence of the magnetic field. So this is all about this diagram, and then we come to the next one diagram. Look at this carefully once again. Wave can have the highest frequency. Now look at these waves. Now question 14 you have to do yourself. It is quite easy, very simple from the discharge tube experiment. You will answer it yourself, right? Now here in the figure below, three waves are being mentioned here, A, B and C. Look in your book. Now here he is asking for which wave had the highest frequency. You should know what is the relationship between frequency and lambda. Here the lambda is being mentioned over there, that longer wave or the shorter wave. So which have the highest frequency? Wave length and frequency, they are inverse to each other. So the wave C will have the highest frequency as the wavelength is very short here, while wave B is having intermediate, so its energy will be in between, or its frequency will be in between wave C and A, while wave A is having the longest one wavelength, so its frequency will be low. You should remember the relationship of frequency and that of lambda, that is mu is equal to C upon lambda. Now what the definition of the frequency and wavelength is? Again we have discussed it in the different slides before. Wave frequency is the number of radiation passing per second, while wavelength is the distance between trough and crest, that is termed as wavelength. Now next one question is that is point out the defects of Bohr's atom that is given in your book and that are also being explained in the slides in the previous lecture, so you have to take it from there. The next question is calculate the energy of electron of a hydrogen atom in the orbit for which the value of n is equal to 3. Directly move to the derivation you have done of energy, and the last one, that minus k2 upon n2, make use of this formula. Find as it is given for hydrogen, so no need to put up z here. Put up the value of k as a constant, that is 2.18 into 10 raised to the power, what is the 10 raised to the power minus, yes, what was the value? Here it is given 10 raised to the power minus 18. It will comes out in the form of joules, but you have to calculate it for kilojoules per mole, right? Then it will give you the answer, right? And here instead of n you have to place 3 square. You have to do it yourself. Now here for question 18, a proton of light with energy transfer minus 19 joules. It is given in your book under the example that is 2.7. Here the energy taken is 10 per minus 19 joules. You have to make use of 10 raised to the power minus 16 joules. So do it yourself and tell me the answers, right? And the last question is also that is that you have to find out the radii and then the difference between them. Do it yourself using the relationship between that of the radius. That if you remember, if you want to calculate the radius for first or the any of the orbit of the hydrogen, we have to apply the formula R is equal to A naught N square. Apply it and find out. Then tell me what your answer is. Okay, we will discuss it during class. Okay.